Using my previous example of finding the number of girls out of 10 births, when the number of girls is binomially distributed and the probability of success or getting a girl was 0.5, I'd like to revisit that example using the TI-84 for the cases when we're finding the probability that the number of girls is more than 6, at least 6, and between 4 and 6 inclusive. Now in my previous examples, I generated a binomial table and a binomial cumulative table using Minitab Express. Now I want to show you just how to get the same pieces of information using the Binomial CDF function in the TI-84. So to find the probability x is more than 6, in the binomial case, that's going to be the probability x is greater than or equal to 7, because here we're not including the case of equality. So we need to jump up to the value 7 in this situation. Again, we could find the individual probabilities and sum them up from 7 through 10. But a quicker way to do this, and we saw this visually in my previous examples, was we could use the CDF, or the cumulative distribution table, and subtract from 1. So the probability x is greater than or equal to 7 is going to be 1 minus the probability x is less than or equal to 6. So to do that in the calculator, we're going to go to our distribution menu, which is right above the vars key, and it's a second key. And we want to select Binomial CDF. It's toward the bottom, so you could either scroll down or scroll up and start from the bottom up. And select Binomial CDF. Number of trials is 10. The probability of success or getting a girl is 0.5. And we're stopping at 6 because the probability x is at least 7 is going to be 1 minus the probability x is less than or equal to 6. So I want to stop at 6. So that probability is 0.828 rounded to 3 decimal places. But again, I need to subtract that value from 1 because I'm actually finding the probabilities in the other direction. I need to sum from 7 through 10, and I'm recognizing the fact that all of the probabilities must sum to 1, so I'm taking out the sum of the probabilities for when x is 0 up through 6. Alright, so subtracting that value from 1, I get 0.172 rounded to 2 decimal places.